that means is, guys, we are going to be talking about specifically how to write and or how to find the solution and how to graph linear inequalities. That's what we're going to be focused on today. So, guys, when I am talking about a linear inequality, guys, a linear inequality is very similar, okay, to a linear equation, but it uses, instead of an equal sign, it uses inequality symbols, right? It uses inequality symbols, all right? And so when we graph, or when we talk about this, guys, the biggest difference that we're going to be talking about is you shade either up or down, okay, on your graph, the way your graph looks, and sometimes you will have a solid line, and sometimes you will have a dashed line, okay? So you either have, you shade up or down, or you have a solid line or a dashed line. Now, when I talk about the a solution to linear inequalities, hold on just a second, guys. I'm receiving a phone call from my daughter. Sorry, y'all. All right, so with when we are talking about solutions to linear inequalities, then what we want to find, guys, solutions are all of the ordered pairs that make our inequality true. Okay? So you can identify solutions a couple different ways. You can identify them by looking on the graph. All right? And if it's in the shaded region or the solid line, then it's true. You can also identify it by plugging it into an equation. Okay? On the graph, it's all the points that lie in the shaded region or on a solid line. You can also see if it's true based on plugging it in to an equation. So you can do this by graphing it, or you can just do it algebraically, okay? And what you can do is you can take your lovely equation right here. 2x minus 3y is less than 15. So guys, notice this is in standard form, right, of our inequalities. Well, guys, can we plug in our x and our y's really easy into that equation? Yeah. So instead of 2x on this first one, it would be 2 times 2, right? Because my x value is 2. And then we say minus 3, and instead of minus 3y, we say 3 times 5. And we want to know, is that going to be less than 15? Is that going to make this inequality true? Well, let's see here. 2 times 2 is 4, minus 3 times 5 is 15, is less than 15. Well, 4 minus 15 that's negative 11. Guys, is negative 11 less than 15? Yeah, that's true. So since that's a true statement, this point is a solution to the inequality. Now, guys, with linear equations, the solutions are very, very specific. They have to be on the line itself. With linear inequalities, you have a whole lot more options because there's an entire shaded region of which can be true. So take a look at this here. Negative 1, negative 7. Let's see if this one makes it true. So I'm going to say 2, and instead of times 2 this time, we're going to say 2 times negative 1. Do y'all feel good with that? Minus 3 times negative 7. And we want to see, is that less than 15? Well, 2 times negative 1 is negative 2. 3 times negative 7 is a positive 21. Is less than 15. So guys, is 19 less than 15? Is that a true statement? No. That is super false. So this point is not in our equation. Does that make sense, guys? So this one is not a solution. 2, 5 is. -1, -7, it doesn't work because it's false when you plug it in. Does that make sense, y'all? Okay, we're going to do this a couple more times. We're going to say 2, and instead of times x, we're going to say 2 times 3 minus 4 times oh, what did I do wrong? Whoops, sorry guys. Whoop. Minus 3 times -4, and we want to know, is that less than 15? Okay, so we would say, okay, well that's 6 plus 12, is that going to be less than 15? Well, that's 18. Is 18 less than 15, y'all? No. So this one's false. So this point is also not in the solution. Okay? And this is my personal favorite, 0, 0, to plug in. Because when you plug in 0, 0, what's it going to do? It's going to wipe out all our variables. It's very nice. So we're going to say 2 instead of times x. We're going to say times 0. Minus 3 instead of times y. We're also going to say 0 is less than 15. So this turns into 0 minus 0, which is just 0. Is 0 less than 15? Yes. So this is true. So this one is also in our solution to that particular line. Do you guys feel good about that? Okay. So one way you can say, is this a solution or not, is you can just plug them in. Another way you can see if these guys are solutions is you guys can graph it, okay? And the way we're going to graph it is very, very similar to the way we graphed linear equations. The first step is that we want to put this inequality into slope-intercept form. Well, guys, if you remember what slope-intercept form is, it's y equals mx plus b. Okay? And please, please, please remember, make sure you flip that inequality symbol if you multiply or divide by that negative number. And once it's in slope-intercept form, we are just going to graph the line. Remember, you use the graph you use the b and the m, right? You graph your y-intercept, then you graph your slope. But when you graph the line, guys, this is super important. You are going to use a solid line for which symbols? Which symbols do you think would be a solid line? Ooh, I like that. Less than or equal to. Also, greater than or equal to. Just like you use a closed circle, you would use a solid line because it's including everything. You use a dashed line or a dotted line if it's just less than or greater than. Just like you use an open circle, right? When you use an open circle with a less than or greater than. Okay, and then these are the shading, all right? So I like this. You shade above the line or up for greater than or equal to. When it's greater than, you shade up. You shade below the line or down for less than or equal to. All right, guys, I don't have a little trick for how to remember the solid or the dashed. You just need to commit that to memory. But for the shading, I actually do have a little trick. So guys, check this out. If I do a greater than sign, I can spell the word up. You shade up. If I do a less than sign, look what word I can spell. Down. You can make a little P for up or a little D for down. Is that kind of cool? So you guys, so that kind of helps us remember. However, this little trick, this only works when you are in slope intercept. Okay? If you are not in slope-intercept form, you can't pay attention to the inequality. We're going to look at it right here for this example. So guys, this example is the same exact one we did up above, but we're going to try to graph it now so we can see what the solution will look like. So guys, the first step is we have to put it in slope-intercept form. So what are we going to do to get this guy in slope-intercept form? Well, we're going to subtract 2x from both sides. Do y'all feel good about that? So then we're left with negative 3y is less than negative 2x plus 15. Are we all done? Now we need to divide by negative 3. When we divide by negative 3, that becomes y is greater than 2/3 x minus 5. Do y'all see that? Do y'all see how I flipped that sign when we divided by a negative? That's super important. Okay? On this one, I had to flip the sign. Okay? So when we look at this and we say, cool. Well, what is my b? What is my y-intercept here? My b is equal to negative 5. What is my m? 2/3. So I'm going to go and graph my negative 5, my y-intercept, and then I'm going to graph my other point, up 2 over 3. And I need to draw a line between these two. But guys, we need to pay attention. This little, since it's greater than, is that going to be a dashed line or a solid line? It's dashed. Okay? So we have a dashed line. So when I connect these two, I'm going to connect them with a dash. Do you guys feel good with that? And we want to think, are we going to shade up or are we going to shade down? Well, let's look here. If it's greater than, we shade up, right? You can think about the little greater than symbol here, right there, right? You shade up. So we are going to shade up. Do y'all feel good about that? Okay. Now what I want you guys to notice is, look, what was the symbol in my original equation? It was less than. What was the symbol when we finally graphed it? It was greater than. So guys, that's why I say you can only pay attention to that greater than or less than symbol for shading if it's already in slope-intercept form. You guys good with that? Also, I want you to take a look. This is the exact same equation that we used up here. And guys, look at all these points. 2, 5. Okay, if I graph 2, 5, is that in my shaded region? Yeah. So if I graph this first point, 2, 5, does that look like it's a solution? Yes, because it's in the shaded region. Okay, negative 1, negative 7. Now this isn't even on the graph. Negative 1, negative 7. I think it would be like down here. Does that look like it's going to be in the shaded region? No. And look, when we plugged it in, it was no. Ooh, 3, negative 4. Ooh, is that in my shaded region? No. So it's not, it doesn't graph it. But then 0, 0. Is that in the shaded region? Yes. So it was a solution. Does that kind of make sense, guys? So you could see, if it's asked, is this a solution of the inequality? You could plug it in and do algebra, or you could graph it and see if they match it on the graph. Y'all see the two ways that we can do that? That's one of the favorite questions that they like to ask you on STARS. Is this point a solution to the inequality? Well, you can do it by plugging it in, or you can do it by checking it on the graph. Y'all see that? Okay, so what we're going to do today is we have a lot of examples. I'm not going to do all of them because I want to make sure that those of you can use the extra time you need for your quiz. But I do want to make sure that we feel pretty good about it. Whew. All right, so let's look at number 1 here. All right, number 1, I'm going to zoom in a bit. So y equals 1/3 x minus 5. Is this in slope-intercept form? Yeah, we're good. So do we need to move it into slope-intercept form? No. So what is my b? What is my y-intercept here? Negative 5, and my slope is 1/3. So I'm going to graph that first. I'm going to go down here. 1, 2, 3, 4, 5. 1/3. I'm going to go up 1 over 3. Down 1, left 3, down 1. Okay, so I'm going to do that a few times. Okay? Now, before I draw my line, let's take a look at my inequality symbol. Is that going to be a dashed or a solid line? It's dashed. So I'm going to draw a lovely little dash because it's just a less than. Okay? And now we have to think, is this going to shade up or down? If it's greater than, what letter can we make? We are going to shade up, right? So we're going to shade up here. Do y'all feel good about that? So that is how you can graph linear inequalities. Okay? Number 3. Can we graph this guy? Yeah? Ooh, but is it in slope-intercept form? No, it's in standard form. So we're going to need to graph it. We're going to need to transfer it into slope-intercept, all right? So we are going to subtract our 5x from both sides. So we have negative 2y is greater than negative 5x plus 12. Now I divide everything by negative 2. And I have y is, ooh, what's going to happen to my sign there, y'all? It's going to flip-flop, isn't it? So instead of greater than, now it becomes less than. Y is less than 5/2 x minus 6. Ooh, I'm going to box that for us so we have it. All right, so there's my y is less than 5/2 x minus 6. So what is my b in this case, y'all? Negative 6. And what is my slope? 5/2. So I'm going to go down here and I'm going to graph my negative 6. And I'm going to count up 5 over 2, up 5 over 2, up 5 over 2. Now I'm going to take a look at my line here. So what kind of line are we going to graph? A dashed or a solid? Dashed, because it's not equal to. Okay? If it was equal to, it would be a solid. So this right here is a dashed line. Cool. And then is it going to shade up or down? We're going to shade down. So I'm going to shade underneath it. Do y'all feel good about that? Guys, the newest thing that we're adding to this is just this last piece of the puzzle. Is it a dashed or solid line? And do we shade up or down? All right, so I want to look at number 5 now. Is this one in slope-intercept form? No, it's in standard form again. So we're going to subtract x from both sides. So we get negative y is less than negative x plus 8. Are we done? No, we divide by negative 1. So we have y is less than or equal to x minus 8. Y'all feel good about that? You guys see how I changed the sign? Because we divided by a negative there. Alright. Now what is my b? It's negative 8. And my slope is 1 or 1 over 1. So I'm going to go up. Oh man. When you have a 1 slope, you go up 1 over 1. You have so many dots you can make when you have a 1 slope. Yikes. Alright. You don't have to do that many. I'm just showing you can, right? So with my less than or equal to line, is it going to be a solid or a dashed line? Ooh, we have our first solid line. So we are going to do it solid. Ooh, it's a little bit wobbly because I don't have my ruler. Okay. And because it's less than, we shade down. You guys feel good about that? It doesn't have to be the most beautiful shading, but you can kind of see it there. Okay? Now for this last one, I'm going to do these bottom 2 actually. Okay? So what I want you guys to do is let's take a look at this. Y is number 7. Okay, is this in y equals format? Yeah, or it's slope-intercept form. But this is kind of a special line. What kind of line is this, y'all? It has a slope of 0, which means it is a HOI, right? This means it's a horizontal line and it has a 0 slope. So it's going to cross through my y-axis at -4. Do you guys feel good about that? But I got to look at my line here. Is that going to be a solid or a dashed line that I'm drawing? That's a solid line. So I'm going to draw a solid line at -4. Okay? Am I going to shade up or am I going to shade down? I'm going to shade down. So I'm going to shade underneath it. Okay? Y'all feel good? Excellent. For number 8 here, okay? Ooh, it's an X. What kind of line are we dealing with? We are dealing with a vertical line, a Vux. It's a vertical line. We have an undefined slope. So this is going to be way over here at x is equal to 7, right? But I need to look at this, guys. What kind of line am I dealing with? If I have a greater than line, is it solid or dashed? It's dashed. So I'm going to draw that 1, 2, 3, 4, do. Got all our lovely little dashed lines here. Oh, but when we see this, we think we shade up. Well, is there really an up to shade when it's vertical? Okay, well, guys, if up is a positive, do you think positive would equate to shading right or shading left? Yes. So up can also be equated with shading when it's only, this is the only case where it shades right versus left. Most of the time it's up versus down. All right, guys, y'all feel good about that? Okay, so this is how you graph linear inequalities. And so what I want you guys to do is a lot of times on your homework, or not on your homework, but on test questions and stuff, they will ask you, do these lines work, or do these different points work for different lines? So what I want you guys to do really quick is for each of the graphs that we've graphed so far, here's point A, which is 0, 0. Here's point B, whoops, which is going to be 6, -2. We have point C, which is going to be -4, 6. And then last but certainly not least is point D, which is -1, -4. So what I want you guys to do is I want you guys to tell me, is A a solution to any of these, right? Is B a solution to any of these? Is C a solution? Is D a solution? If we take a look at A really quick, guys, well, that's 0, 0. Let's check it out. Is it a solution for number 1? Yeah, it's in the shaded region. Is it a solution for number 2? No, it's not in the shaded region. 0, 0 right here. Is it solution for number 5? No. It's actually not a solution for any of the rest of them, right? Because it's not in any of the shaded regions. Do y'all see that? All right. Let's see if B is a solution. All right. 6, -2. So I'm going to count 1, 2, 3. It gets a little hard when you've like drawn on here. Okay. 1, 2. Okay. So is it a solution in my first equation? Does it land in the shaded region? Yep. So we're good. Sorry about that. All right. So then we have 6. My allergies are like driving me nuts. All right. We're going to do 6, -2 again. Ooh, is it a solution for number 3? Yeah, because it's in the shaded region. So this one works. That's a good B. Okay, ooh, 6, -2. Interesting. For number 5, it lands right on the line. Is it a solution for this one? Okay, it is for this one because of the solid line. If it was a dashed line, it wouldn't be a solution. If it lands on a dashed line, it's not a solution. If it lands on a solid line, it's good. So this one works, but only because that line is dashed. Do y'all see that? Okay. I mean, only because that line is solid. 6, -2 would not be a solution. 6, -2 would not be a solution on those bottom two. So you guys see the kind of thought process that you go through for each of these? I don't think actually C works for any of these. Oh, I think it works for the first one though, doesn't it? -4, 6. Yeah, it does. Okay. Oh, and, oh, you're right. Does it? C? Let's see. -4, 6. Ah, yeah. So it works for this guy. No, not for this one. It's going to be like way up there. Not for that one. It's way up there. Not for this one. So none of these other ones will be good for -4, 6. But D will work for number 7, won't it? -1, -4. I don't think D works for any of these guys. Oh, man. Number 1 is just popular. All of them work for number 1. So D, -1, -4, that works. It doesn't work for 3, 5. Ooh. It does work for 7, but it doesn't work for 8. So poor 8 has no points. That works. All right? Do y'all kind of understand the way we're doing that here? So you can look for a solution a couple different ways. You can plug the points in, or you can find them on the graph. Okay, so what I want you guys to do is if you, we are going to be done for now, so you guys can get started on your homework.